All right. I wanted to talk to you a little bit about a tool that you're going to be using in the course. And it's a way to help manage the complexity of memory leaks because it's really easy to forget to do that delete. The example that we've just been working on, all right, if I do Emacs main.cpp, Emacs main.cpp, this example is pretty simplistic. I'm creating the int here, and then I'm deleting it here, remembering to delete here. But there are going to be situations where you might create a more sophisticated class that has dynamically allocated members in the class, and then it's complicated to track down those members and delete them if you have them in a collection like an array or a dynamic list or something like that. So it's not always obvious. But it would be nice to know if you run your program if you have any memory leak issues. And so one way that we can do this is we can use a special program called Valgrind. So I want to show you that. So I'm going to comment out that delete and make the program. So now I definitely have a memory leak. I'm forgetting to clean up that integer. And now if I run Valgrind, so the command is, you can see it here, Valgrind -- leak check equals yes, and then I'm giving it the main program. So it's going to run the main program. And what we're looking for is the leak summary, all right? So your code, or this code that I wrote, said it's lost 4 bytes in 1 block. So those 4 bytes are the 4 bytes of the integer that we forgot to delete. So it's basically giving you information that you definitely lost some data, you've forgotten to clean some data up, all right? And so what I'm gonna require you to do is every time you submit a program to me, you must run Valgrind on the program and verify that there are no memory leaks. So that's absolutely required. So like you're gonna get a 2 grade reduction. So if you got an A on the assignment, it's gonna be a C if you don't run Valgrind and verify that there aren't any memory leaks. All right. It's not going to be a C. It'll be an 80. So we'll go from 100 to an 80. So you're going to lose 20%. That's typically what I do for the memory leak stuff. All right. So how do we fix the memory leak? Let's go back into that main program, and we'll uncomment the delete IP, which was the command that said, hey, this new int, go onto the stack and get rid of that int. Track it down, follow IP onto the heap, sorry, and find that chunk of memory and delete it. All right, so save that, quit, make, and we'll run Valgrind again against me. And now you can see that it is getting upset about an invalid read of size 4, but it says that all heap blocks were freed. There are no leaks possible, so we've gotten rid of the memory leak. Still not happy about that invalid read of size 4. That's happening because we now have that dangling pointer issue. Oops. So let's correct that as well. We'll just comment that out for right now. Run Valgrind again. And now it's nice and happy. There's no errors, 0 contacts. Life is good. We've done a good job. So if Valgrind reports any kind of error, not just a memory leak, but like a read error, that's something else that you have to track down because it's very dangerous to be reading chunks of memory that you're not supposed to be reading, right? If you've done a delete and you now have a dangling pointer and you try to read it, that's very dangerous because it means that your code may behave in a non-deterministic way. A chunk of memory that you freed, that you're reading, can be used by other methods that you've written or potentially system library methods that you don't know anything about. And so the value at that location that you're reading is unpredictable. So you want to try to avoid that.